So let us look at examples using the laws of exponents. So the first law was a raised to 0 is equal to 1. So anything raised to 0 is equal to 1. Let's say we have 2, base of 2 raised to 0, this will be equal to 1. Anything minus 2 raised to 0 is equal to 1, or anything 100 to the power of 0 will be equal to 1. Second law was a raised to a raised to 1 is equal to a. That means if you have a base 2, 2 to the power of 1 will be the number itself. Okay. Anything to the power of 1 will be the number itself. Okay. So minus 10 to the power of 1 will be equal to minus 10. Fifth, or 100 to the power of 1 will be equal to 100. Third, the third law that we discussed was a raised to m multiplied by a raised to n will give us a raised to m plus n. So when there is a multiplication sign, the powers get added. Fine. Let's take an example. So the base is same here, a and a. So the base will be common, a, and the powers gets added. So let's take a base 2, 2 to the power of 3 multiplied by 2 to the power of 4, which is equal to 2 to the power of 3 plus 4. Then 3 and 4 are powers, they get added. So this will be equal to 2 to the power of 7. Let's take another example. 3 to the power of 5 into 3 to the power of minus 1. So this will be equal to, here again, the base is same, powers are different, and there is a multiplication sign between them. So this will be 5 minus 1, which is equal to 3 raised to 5 minus 1 is 4. Okay. 10 to the power of, or let's say 7, 2 into 7 raised to 1 upon 2. This will be equal to 7, or no, let's not take this example. Let's take minus 3. This will be equal to 7, 2 minus 3. And this will be equal to 7 raised to minus 1. And this 7 raised to minus 1 will be equal to 1 upon 7. We have already studied in our loss section. In that video, we have seen that anything, any number to the negative power, it travels in the denominator. Okay, and the sign changes. यानी कि अगर a raised to minus n है तो वो क्या हो जाएगा, ये a raised to n ट्रैवल कर जाएगा कहाँ पे, डिनोमिनेटर में ट्रैवल कर जाएगा. That is why either I can write, because 7 raised to 1 is 7 only, so I can write 1 upon 7 also here. All right, let's take another example. The fourth law. The fourth law states that a raised to m divided by a raised to n, this will give us a raised to m minus n. Okay, so when there is a division sign, the powers will get subtracted. So let's say 2 raised to minus, or let's say 2 raised to 4 divided by 2 raised to 1. This can also be written like this, 2 raised to 4 upon 2 raised to 1. So this will become 2 raised to 4 minus 1, which is equal to 2 raised to 3. 4 minus 1 is 3. Another example can be 2 raised to, or let's say, let's take a different base, 5 raised to 4 divided by 5 raised to minus 7, or let's say 1, or let's say 1. So this will be 5 raised to 4 upon 5 raised to 1, which is equal to 5 raised to 4 minus 1, which is equal to 5 raised to 3. And let's say if we have 7 raised to, or let's take 3 raised to 4 divided by 3 raised to minus 2. Okay. So this will be 3 raised to 4 divided by 3 raised to minus 2, right? This can be written like this. And 3 raised to 4 minus of, be careful of this minus sign. This minus sign here is because of this division. Okay. There is a division between these two exponential forms. That is why we have put a minus sign. Now this minus sign inside the bracket is for this minus 2. Okay, this number is getting subtracted from 4, minus 2 is getting subtracted. Now this can be written as 3 raised to 4 plus 2, which is equal to 3 raised to 6. Okay, so this is the fourth law. Now the fifth law states that a raised to a into b, ab is a into b raised to m, this is equal to a raised to m, b raised to m, or you can say multiplied by. So what happens is this power is getting distributed to both the numbers inside the bracket. Okay, so this power comes, ये दोनों basis पे आ जाता है. So if we have a number, let's say 2 into 3 raised to 5, this will be equal to 2 raised to 5 into 3 raised to 5, or for that matter 10 raised to 2 can be written as 2 into 5 raised to 2, and this can be further broken down as 2 raised to 2 into 5 raised to 2. Okay, so here in this example I want to explain you that this LHS and RHS are common, and this is very useful. This law is also very useful. So 2 raised to 2 into 5 raised to 2, if we look at the RHS, let us see what we get. 2 raised to 2 is 2 into 2 into 5 into 5, which is equal to 4 into 25. 5 into 5 is 25, and 2 into 2 is 4. So 4 into 25, 25 fours are 100. So our RHS is giving 100, and 10 raised to 2 is equal to 10 into 10, which is equal to 10 into 10 is 100. So we see left hand side and right hand sides are equal. What I mean to say here is, or highlight here is, 10 raised to 2 can be broken down into multiples of 2 and 5. Okay, 10 can be broken down. This is very useful. This concept is very useful. So 10 can be broken down into 2 into 5 raised to the common power 2. Now this common power 2 is getting distributed to different bases here. Okay, so we have seen till 5. Let's discuss or see with an example law number 6, that is a upon b raised to m. Now here again, previously we saw there was a multiplication between a and b raised to m, and it gave us, the power got distributed to a and b. Here as well, the power is a upon b raised to m. So this power will get distributed to a raised to m upon b raised to m. And this can be written as, let's say 2 upon 3 raised to 5. This will give us 2 raised to 5. This power will shift to 3 raised to 5, both the bases. Okay. Now the seventh one is, as I said, mentioned earlier in my previous video, that this is very useful. A raised to minus n is equal to 1 upon a raised to n. This entire thing, a raised to minus n, will travel into the denominator, and the sign will change. The sign of the power will change. So let us look into this with an example. 2 raised to minus 1 will be equal to 1 upon, this entire thing will come in the denominator, and the power will change from minus 1 to plus 1. Okay, let's take another example. 5 raised to minus 3 can be written as 1 upon 5 raised to 3. Similarly, if there is a number written like this, 5 raised to minus 1 can be written as 5 raised to 1. Okay, you can shift from denominator to numerator, numerator to denominator, but be careful whenever you are shifting, whenever we are shifting from numerator to denominator, the sign of this power will change. Okay, the sign of this power will change. Okay, let us discuss the eighth one. Eighth one is a raised to m, the whole power n. Here both the powers will get multiplied. A raised to m into n. Example would be 2 raised to let's say 7 to the power of 3. So this will be 2 raised to 7 into 3. The powers are getting multiplied. 7 into 3 is 2 raised to 7 3s are 21. Now the ninth one. Ninth one is also important. Ninth one states that a raised to m upon n. Now this is important. Why? Because here you have to be careful of this m upon n fraction, because the power is in the form of fraction. So now there is a numerator m and a denominator n. This denominator comes outside the square root, and a raised to m. This m, the numerator will come as the power inside the square root. Okay. Remember, what you need to remember is, if you remember one thing, that this denominator is coming outside the root sign. Let's take an example. So 2 raised to, let's say, 1 upon 3 is equal to 3 root of 2 raised to 1, or this can be written as 3 raised to 3 to the root 2, uh, and this is 3. Okay, the 3 has come outside the root sign. This is the cube root of 2. Okay, let's say 4 to the power of 1 upon 2 can be written as, there is a denominator 2 and a numerator 1. So denominator will come outside, denominator has come outside the root sign. 4 to the power of numerator 1, which is equal to square root of 4, which is equal to 2 into 2, and this is equal to 2. Okay, square root of 4 is 2. So by default, when we don't write anything outside this, it is 2 by default. All right, the 10th law, this is not the 10th law, it's not a new law, as I mentioned. A upon b, the base is in the form of fraction raised to minus n. This can directly be written as, a upon b can be written as, a upon b raised to minus n can be written as b upon a raised to n. This power sign of the power will change. Okay, we take a reciprocal of this fraction simply, and the sign of this power will change. Say for example, we have 2 upon 3 raised to minus 2. This will be equal to, or let's say, let's take a different, minus 5. So this will be equal to, or let's say, uh, let it be minus n only. So this will be 3 upon 2 raised to n. Okay, this is very useful. This is not a new law, as I have mentioned earlier, that this is just a continuation of this law. A raised to minus n is equal to 1 upon a raised to n. Okay, this entire thing has come in the denominator. So again, a upon b raised to minus n will be equal to a upon, sorry, b upon a, or let me write it like this, in this form, a upon b raised to n. Now this will become 1 upon a raised to n upon b raised to n. Okay, by the law, that this power will distribute to the numerator and denominator. Okay, we have studied this. A upon b raised to n will be equal to a raised to n upon b raised to n. This we know. And the rest, the denominator, this fraction which is below the denominator, will be reciprocal. Okay, so this will become b raised to n upon a raised to n. Now when we have a common power, we can take it as common, b upon a raised to n. That's how we are getting a upon b raised to minus n is equal to, we simply reciprocal the fraction or the base, b upon a raised to n. Okay, this is also very useful. So that was the explanation for the laws with examples. I hope you have understood it. Okay, so now look at uh, the example sums of I'm taking from R.S. Agarwal. So the first sum says, example number 4, written in exponential form. We don't have to solve it fully. Let us take down the question. The first question is 3 upon 4 raised to 7 multiplied by 3 upon 4 raised to 5. 3 upon 4 raised to 5. Okay. So here we see the bases are same. The powers will get added, and there is a multiplication sign. The power gets added. So this can be written as base 3 upon 4, 7 plus 5, which is equal to 3 upon 4 raised to 12. Okay. The second question is, let's take the second question here. And the second question is minus 2 upon 5 raised to 11 into minus 2 upon 5 raised to 4. Here again, the base is same, the powers will get added. So minus 2 upon 5, 11 plus 4. Okay. Which law we are using here? We are using this law. A to the power of m into a raised to n is equal to a raised to m plus n. Or we can write, because this is in the form of fraction, so you can say a upon b raised to m into a upon b raised to n is equal to a upon b raised to m plus n. This is the same law. This is in the form of fraction. The base is in the form of fraction. Here it is a single numerator only. Okay, so now there are two questions only in this question. So let's take the fifth one. We don't have to simplify this. We can simply write the answer here as minus 2 upon 5 raised to 11 plus 4 is 15. So this is our answer. Question number 5 or example number 5. We have to simplify and express each as rational numbers. So simplify and express each as rational numbers only. So this will become 2 raised to 6 upon 3 raised to 6, which is equal to whatever 2 raised to 6 is. Okay. So 2 raised to 6 will give me 64, and 3 raised to 6 will give me 729. Okay. So 2 raised to 6 and 3 raised to 6, you can do it like this. 2 raised to 6 is 2 into 2 into 2 into 6 times. Okay. So 2, 3, 4, 5 and 6. Again, you can multiply and you will get 64. And 3 raised to 6, you will get as 729. Okay. Okay. Example sum number, we were solving example sum number 5 2, 5 का सब पार्ट 2, so -3/4 raised to 3 into -3/4 raised to 2. Bases are same, -3/4 -3/4, so the powers will get added. So -3/4 raised to, directly we'll add it, and this will give us -3/4 raised to 5. Now this can be further solved because we have to solve it further, because they have stated that we have to simplify, express as rational numbers. So -3 raised to 5, we know that when there is a, or let us first distribute this power to this fraction. Okay, so this 5 will this power will come on the numerator, and this the denominator will distribute. So this will be like this. Okay, can be written. And when there is a negative sign inside and the power is odd, we know we will get negative sign here. Okay, and 5 will give me, it should give us 243 upon 4 raised to 5 will give me 1024. Yeah. Now here, one important thing we need to note is, this is the answer of this sum. So here the important thing which we need to understand is, uh, let's say -1 raised to, we have 10, okay, and -1 raised to 9 we have. So when we have the sign or the power as even, when we have an even power and there is a negative base, so this will give me, let's take 1 and 2. Okay, so here we have the power as odd. Okay, and here the power is even. So remember one thing, that this will give me minus sign whenever there is an odd power, will give me minus sign, the result will be minus in minus. Okay, and here the result will be positive. Whenever we have even sign, the result will be positive. Okay, why we are getting like this? Let's take an example and understand this, because this is also important, and a lot of calculation errors happen here. So let's say we have -1 raised to 3, and let's say -1 raised to 4. We have like this. So -1 into -1 into -1. This should give us, minus into minus is plus, plus into minus is minus, and we'll multiply 1. 1 into 1 into 1 is 1. Here -1 into -1 into -1 into -1. So minus into minus is plus, plus into minus is minus, and minus into minus is plus. So we are getting the answer as positive. Okay, so whenever we have uh, negative base and there is an odd power, then the final answer will be negative. And we have, whenever we have a negative base and even power, the final answer will be positive. Okay, so the question here is 5/7 raised to 9 and 5/7 raised to -3. So we see the base is same, common, so we can write 5/7 raised to, the powers will get added, so 9 minus 3, which is equal to 5/7. 9 minus 3 is 6, and these powers will get distributed. So I can write 5 raised to 6 upon 7 raised to 6. Now 5 raised to 6 is how much? 5 raised to 6 is, okay, this is not 9, this is 5. So this will be 5. Okay, so 5 minus 3 is 2. So this 2 will get distributed. So 2 here and 2 here. Okay, so this will give me 25 upon 79. Sorry, 49. Okay, so the question was the power was 5, not 9. Let's take the sum. Fourth sum is minus 3 upon 5 minus 3 upon 5 raised to minus 3 into minus 3 upon 5 raised to 2. So this will give me bases are same. Let's check the bases are same. Minus 3 upon 5 minus 3 upon 5. The powers will get added. So minus 3 upon 5 we will write as it is and we'll add the powers. So minus 3 plus 2. This will give me minus 3 upon 5. So this is 5. The whole raised to minus 3 plus 2 is minus 1. Okay. And this can be written as whenever we have a negative sign, the fraction, the base, if the base here is in the form of fraction, what will happen? It will be reciprocal. Okay, so 5 minus 5 upon 3, and the sign of the power will change, will be 1. Which law we are using here? Important thing is a upon b raised to minus n is equal to b upon a raised to n. So this becomes the fraction which is in the becomes reciprocal, and the power sign of the power changes. Okay. So this is example number 6. Express the following as rational numbers. The question is 4 raised to minus 3. So this can be written as 4. Directly this can be written as 1 upon, because the power has a negative sign, so we'll bring this entire thing in the denominator and the sign of the power will change. Which law we are using here? A raised to minus n is equal to 1 upon, this entire thing will come in the denominator and the sign of the power will change. This is the law that we are using. Now we have to solve it as a rational law. Will give you 1 upon 64. The second one is minus 3 raised to 5. Yes. So minus 3 raised to 5 will be how much? So minus 3 raised to, there is no negative sign in the power. So what we will do is, I have told you that there is the power is even or odd, we have to check. This is odd. Odd power means we will get a negative sign. Final answer will be in the negative. Okay. So we can directly do 3 times, 5 times 3, and the answer should be, I'm sorry, this is 3 raised to minus 5. So this will be 1 upon minus 1 upon minus 3 raised to 5. The entire thing will come in the denominator and the sign will change. So this should be 1 upon, because there is a minus sign and the base has minus sign, power is odd. So we'll get 1 upon minus 243, and we can write this minus sign in the numerator. Same, a raised to minus n is equal to 1 upon a raised to n. This is the law that we have used here. Okay. Let's take the third one. The third one states that it is 1 upon 2 raised to minus 4. So this will be, when there is a minus sign, we can write, we can do the reciprocal, and is in the form of fraction. The base is in the form of fraction and we have a minus sign. So it is in the form of a upon b raised to minus n. This can be written as b upon a raised to n. So I can write 2 upon 1 raised to 4, which is equal to 2 raised to 4, which is equal to, because 1 raised to 4 is Give me 1 only. So this can be written as, I will write it here. So 2 raised to 4 is how much? 2 into 2 into 2 into 2, and 1 will give me 1 only. So 4 into 4, 4 fours are 16. This is my answer. The fourth one is minus 2 upon 5 raised to minus 3. This again can be written as, because there is a fraction, the base is in the form of fraction and there is a negative sign. So this can be reciprocal. 5 upon minus 2 raised to 3. The sign will change. Remember to change the sign, because whenever we are reciprocating, we don't change the sign. So this will be as error. Okay. So 5 upon minus 2 upon raised to 3. This will give you 5 raised to 3 upon minus 2 raised to 3. And 5 raised to 3 is how much? 5 into 5 is 25. 125 minus sign can be taken into the numerator, and